Miss Tran, thank you for bringing in your work today. I really appreciate it. As we start smiling for the camera, everybody can wait. The standard. Gather and synthesize information about the technologies that have changed the way humans influence the inheritance of desired traits in organisms. And the topic is genetic engineering and mutations. So, what, Ms. Tran, did you want the kids to know and show specific to this standard?
Sure. With no, I wanted students to build on their knowledge that traits are a reflection of genes, which are responsible for synthesizing proteins. And what I wanted them to do was to be able to change genes, so transferring genes from one organism to another. And how each trait is isolated to like one gene. I mean, that's kind of like a basic understanding of it. I also taught them, like, in showing that, I also wanted them to know about CRISPR technology. It's one tool that scientists have started using to be able to splice and edit genes.
What's CRISPR? What is that?
CRISPR. It's like cluster. It's
Doesn't
yeah.
matter. I knew it was an acronym.
Yeah.
And this was a technology?
Mhm. We also learned about cloning, but that wasn't really part of the show. And then I have like a bunch of different genes of interest, but they could pick and choose different genes.
I think 8th grade is the only one that has this in their scope and sequence, right? Or do you
This
have
was
it
part of
from our-
mutations.
Mutations, yeah, I know what
It was just the
mutations.
engineer of it, because I didn't really like
Mutations.
So with this science standard, is there anything that anybody else wants to add on the no? Because I know that CRISPR and cloning are technologies, so those are mentioned in the standard. And then to know that traits are a reflection of genes, and proteins are the building blocks, right?
And genes are inherited from parents.
That kind of
and
piggybacks
sexual
off of the genetic
reproduction.
genetics.
Genes are inherited.
I think there was also a part about how like this is like the crossroads of ethics and science. You know what I mean?
Yeah, we're
like
yeah.
a brief.
Oops.
I don't know.
I'm gonna put that as a star.
Yeah, yeah.
Because it doesn't say anything about here.
It doesn't
about
say it
what
there,
that-
but I know that that's kind of how Melissa
It's-
presented it.
It's a good like
Yeah.
talking point.
So
Mhm.
yeah,
Okay.
it's good.
And then what about on the show
Yeah,
side? Because I mean, the change, the transfer of genes from one organism to another, that's the inheritance piece, right?
Mm-hmm.
Yes.
And then pick and choose genes of interest. For what purpose is this?
Genes of interest to solve a problem with technology. So they have to specify like their problem, which they would solve by genetic engineering.
What about like the deeper understanding of how mutations happen? You know, even though it's not in the standard, like you kind of have to know the process of like protein
That's like
synthesis
a
or
different.
like.
That's a different standard. I think.
Okay,
I
okay,
didn't
no
really
problem.
jump into.
Alright. So, what is the student work that we're gonna be looking at?
So there's like their kind of like preparation packet. I had a rubric, and they were creating posters / presentations based on different genes to solve a given problem that they identified.
Cool. Do you have an exemplar for that work?
I don't have one that I made.
Do you have a student exemplar?
Yeah.
Somebody that did an awesome job?
Yeah, let's see. Actually, Renolfo did a great job.
Wait, they had a made up gene or they actually identified?
No, these are real genes
Real
that
genes,
they
okay,
read.
cool, so they had to do a little bit of research or?
Mhm.
Okay.
Yeah.
Easy. Anyway.
Right, so for this, they had, I don't know if you can see it. So this one was the anti-malaria research on what malaria is, where to find it, and mice don't get malaria. So they were going to use CRISPR to put that anti-malaria gene into mosquitoes. Talked about CRISPR. And some sort of conclusion.
You said that there was a rubric,
Yes.
and so maybe we can write down what the rubric said, and then see if there, we can do like a gap, or try to identify a gap between the rubric and the standard breakdowns.
Where is it? It's on the most of that. They don't have to see where it's in.
How many points on the rubric for them?
It was a total of, it was like from 1 to 4 for each, and then there were 2. So it's like 8 total.
Yeah. I mean, or
Oh,
there
here
were
it is,
two,
Megan.
like,
It's right here. No,
2
okay.
bullets?
Well, the rubric didn't print out. I had to,
Just, I mean, we can just like, summarize, like, what does it say, what's the first point?
let's see, mutation.
All aspects of the engineering planning guide.
What is it?
Whatever that is.
Let's see. Bring it up.
Oh, this wasn't engineer it. Right? Or,
Yeah, it was an
there's a
engineer.
third one.
So I had a checklist and then a rubric.
Let's go with the checklist.
Okay, so for the checklist,
Mhm.
the focus problem relates to genes and traits.
Focus problem
In the checklist, yeah.
relates to what?
Genes and traits.
Genes and traits. Okay, next check.
Displays understanding of, quote, gene of interest and its function.
Understanding of gene of interest and understanding
Right, and function. So instead of under the second understanding, it's function. Sorry. And its function. And then finally, accurately depicts how CRISPR technology works to create genetically modified organisms.
actually depicts how CRISPR technology
Creates GMOs.
creates GMOs.
Yeah, with artificially selected traits.
Cool. Let's push her a little bit and saying, is there a gap between this checklist, which is what the expectation is for students, and the know and show chart? Is there a gap there? In other words, is there something missing, or that's something that could be a little bit clearer for students as they work through this checklist?
I guess a show I didn't come up with. Oh, am I allowed to?
Yes.
Okay. I'm like, I don't know if this is that stage yet. Showing CRISPR, like a diagram or explanation of the process of CRISPR. Sometimes summarize that.
Say that again? You're asking, like, I mean,
For the show. In order
Depends
to
on
show
what your
that
audience
know what
is, you know,
CRISPR is.
yeah.
oh, okay.
Yeah.
Mm-hmm.
But yeah, like that's a good 21st century skill, right? Like don't just assume that people
Yeah.
Mm-hmm.
know what that is.
It's very
If you can
21st.
teach it, then
Well,
you
and
know
especially
it.
like 8th graders, right?
Yeah.
So, I'm reading through this. Focus problem relates to gene and traits. When you say focus problem, they know what that is? I don't know what that is.
Yeah,
It means
yeah.
they solve a problem. That was
So whatever
engineering.
problem there is, okay, they, okay, they
Just like
engineer
this
it.
You
one
can't
was
just do this 'cause
malaria,
it's
right?
fun.
Your-
Yeah, did they choose
Yeah.
a problem that was relevant, and that was the malaria one.
Okay.
That was
You gave
good.
them some ideas, Megan.
Yeah,
and
I
they came
gave
up
them
with
like
some
12
other-
ideas.
Okay, great.
What's GOI?
Gene of interest.
Gene of
It
interest.
displays understanding of gene of
So
interest
what
and its
was
function.
his gene of interest?
They have like a list of 12 to
But what
But
did-
theirs was kind of like what
Anti-malaria
causes
gene.
malaria, right?
The anti-malaria
Where
gene.
malaria is transmitted.
Did he get into sickle trait at all?
We didn't get into it, or I don't think we did.
Alright. And then
That's Ray's favorite ailment.
accurately,
Is it?
it's
Sickle cell.
fascinating to me. Accurately depicts how CRISPR technology creates GMOs with artificial selected traits.
Alright, so in order to do that, you have to know or show.
Who came up with this checklist?
Oh, most of them.
Mosamac, it's
Oh,
right
okay.
there.
Alright.
And this is also like their project.
Mhm.
That's why there's no way to write an exemplar for it. 'cause
Yeah.
they choose it.
That's why, like, when I gave Megan my genetics exemplar, I was like, I tried to follow the checklist and do the best job I could, but they.
Oh yeah, I mean, but this is a great guide for students, because if they knew all of these things, right, then they should get a good outcome.
Yeah, and
Alright.
it was like, it was so vague too. Well, I mean, like, it wasn't too constraining. Like, students could do whatever they wanted.
That's kinda what engineering is all about.
I know.
Right. And so
Just
a lot
like
of them were like,
explore
what am I
topics.
supposed to do?
So, you have some student work.
Mm-hmm.
Let's look at the student work now that we have a good, I mean, because with Mosamac, I think the checklist is the exemplar.
Yeah,
I mean,
Yeah.
for engineer.
for the engineering.
It depends what lesson you're on, because like for lesson 1, they give you the exemplar, you know what I mean?
Gotcha.
Right.
Yeah.
Would we like to like
Engineering
look,
is the only one.
Yeah, just give us a
take a
couple
look
each.
at like student work with their corresponding, I guess, presentations?
Is this just leading up to the presentation?
Yeah.
It's like the planner, right?
Yeah, it's like
Yeah.
how they plan for it with their.
Yeah, just give us can you share a couple presentations with us?
Alright, so I'll share this one.
I like this planner.
Can I see it?
Like where it says what
Yeah, this is
organisms have this gene, like that kind of leads you to the
Did you
focus
make that,
problem
or did
and like
Mosamac have that?
Most of math and then.
you adapt it. I do that too.
Yeah.
I know. I always have to adapt things because I'm like, this
And,
is
like,
weirdly
typing in
worded.
there.
Yeah. Yeah. But like that's how you display understanding of the GOI and its function. The gene of interest is like
Holy
knowing
cow.
what organisms have this. You know.
You went overboard on that. And then. And I have brand.
Like look at how cool this is. This gene reduces the rejection rate of organs from pigs.
I'm waiting.
I feel like they're teaching science.
It's good, it's rigorous.
The first thing I'm noticing is the
Love
amount
this
of
little piggy
detail,
on extra notes and drawings.
but at the same time, the guidance that the kids get in terms of like the graphic organizer for this CRISPR library of genes of interest. The thing that stands out to me here is like, okay, I have the gene, because the teacher did that work for me, is like, what is the problem with this thing and what is the solution? I think it's,
Did you do that together?
They did it in stations, so like they rotated each station for a different gene they read an article on.
So that's how they gathered their information, like background knowledge. That's what
yes, that's a good idea.
Wait, is there actually a gene in the humans that reject?
I mean,
Is
it's
it related to a gene or is that kind of made up?
sort of, yeah, well, yeah, these are all like based
I
on
didn't
real
know that.
articles. And
I learned something.
I always learn
I
something.
thought it was just organ reject. I didn't know it was related to a gene.
And then this is Brandy's.
Oh, is this, Megan, this library, is that the rotation?
Yeah, that was
Okay.
like the 12.
Gotcha. It seems like a lot of them did one that interests them. Did
It's
they?
just working partners.
Yeah, yeah. We're the partners.
Like this kid got it. It will allow humans to live off pig organs. Like got the point of like the problem
Is that
and the
Gabe?
solution.
This one's maybe.
This is Alberto.
Oh, yeah. Randy was in his group too. He was absent for a little bit.
See, like here where it says from which organism will you extract a copy or gene of interest, they just put organ compatible genes. Which is like, yeah, it's, that's what Megan just explained, is it's kind of like a,
It's like I didn't learn about it till college because it's so new.
almost kind of like, trying to think of an analogy.
Scissors for DNA, like control find.
You know how you can like isolate genes when you're doing DNA. It's kinda like that, but like even more detailed to the point where you can see differences in the genes presented to you. Does that make sense?
Yes.
So you can actually distinguish, this is this gene, this is this gene, right?
Yeah.
Rather than like with the, what did we call it, the electrolysis with the gel
Oh,
and
yeah,
stuff.
yeah, yeah.
That's just like based on like
But-
almost like a weight and how,
Right,
much
and
it
it shows you
matches.
the sequences,
Yeah.
right? And so, but
But
this
this
is
is
like more
like-
isolated.
like, okay, I'm looking at this breast cancer gene and I'm able to see the similarities of like how that
And we
gene
really
is
can't see it,
synthesized. But
because-
like I can,
But
I
yeah,
can understand it
enzyme, right?
better,
If I'm
you
not
know what I mean?
mistaken.
But it's like you're able to isolate to one gene.
So it's an enzyme that finds the specific gene that controls whatever it's eye color, hair color, whatever it may be. And then it finds it and it even,
Like
if I'm not
lineage
mistaken,
or
yeah, it actually can cut
You
that
can
out.
isolate it, I
Huh.
guess is a better way.
Yeah. It's like a control find for the genome.
Yeah, there you go, that's a great analogy. It's like,
She's
I want
teaching.
this one, and it's like, bing!
Yeah.
Yeah,
Alright,
that's
so show
good.
us what you got there,
Control
Megan.
find on the-
Okay, so I have a few student work I have. So I based it off of, like the packets you had. So I have Beto, Michael, and Manny. And then we have Brandy. I think Brandy's out. We have Brandy. Who else do you have? This is
I have
Edwards.
Alberto, but yeah,
Mhm.
Arnolfo's.
that's the one you showed us.
Yeah.
You showed us a pretty good one. Let's
Yeah.
see, not so good.
Yeah, can we maybe see like,
Well, I have blank ones.
this one's very, yeah,
Um,
that's like my Pokemon project.
Not so blank, maybe.
Maybe not so blank, but maybe like, one that was missing the boat a little bit in terms of like,
Like
What you
Brandy's
wanted
is
in the
almost
show.
there, but not quite.
Yeah,
Like
so-
she says like by testing them, okay?
Right.
But how do they do that?
So Beto, Michael, and Manny, they were almost sort of there. Like they knew what the problem is, and they knew like, okay, so like the organism is coming like a pig. They based it all on this article, but then they didn't really explain what CRISPR was when it came down to it. They kind of like stopped after the problem. So from which organism will you extract and copy your gene of interest?
Oh, that's the one I was reading. I was like,
Mhm.
organ compatible gene. Well, what does that mean?
Yeah, right.
okay.
Where would it be found is like what it's really asking.
Mhm.
Yeah.
What, in
Yeah,
terms
most
of
of
percentage,
it's-
what do you think the breakdown would be of percentage of kids that were like exemplar versus kind of, almost got it, or just left blank? What's like the percentage breakdown you think of those?
From like exemplar really understanding it to like
Mhm.
maybe understanding it to like blank,
Yeah,
probably like 25, 50, 25, maybe like a bell curve I'm seeing.
Okay. When you said, wait, so,
Or even more, I'm not sure.
is there a commonality with the 25% on the low end of that bell curve?
Trying to
That
gaps
you
are.
would think or where the gap is between, theirs and the exemplar. And so what I'm trying to get at is, what would your, advice for the kids, or what would your, instruction look like for the next go around of a presentation like this?
Be wary
Yeah,
this, or don't do this, this.
Or is there some guidance that the kids could benefit from?
Yeah,
I
maybe
mean, I'm
like-
asking the group, I don't know.
I don't know. If anyone
I'm
wants
asking
to
you
do
too,
this.
but
Okay.
I mean, yours, what do you think?
Yeah.
How
I
will you
think-
approach this, moving forward?
So for me, I like didn't give them too much structure. Normally I'll be like, slide one needs to have this, slide two needs to have this. I wanted them to do their own research based on the article, but I think they could benefit from a little bit more structure, like a template, from how they can phrase their presentation in the future. What exactly they could have. See what
Almost like
they-
sentence frames or something.
Yeah, I thought like the checklist would be like, okay, take this and run with it, but it might need more scaffolding.
Oh, more scaffolding.
Use this slide to explain to a 3-year-old what CRISPR is.
Let's do this then.
Yeah.
Let's like take 3 minutes each person and write down like a scaffold where, cause we all do this, right? We do all the
Yeah.
presentations. So what kinds of scaffolds do you think that different grades would use? I think this is, getting into, is this modeling or guided discourse? You think?
This should be modeling,
Should
there's only
be
25% about it.
I mean, it was like,
Yeah, cause most students are struggling.
right, it's mostly based on like page 5.
So like
Like
Megan,
their
did
own
you,
design work.
oh, because you didn't have structured slide, and you didn't do an exemplar slide, So I did this for the Pokemon project, which was totally like, waste your time before winter break, but, I did an exemplar, shared it with them in Google Classroom, and then they had their own blank slate. So if they wanted to like copy the template from mine, they could, does that make sense, like doing slide for slide? And I told them that, but I also said they had to do everything that's in mine, but they could do on top. So it's like they had a structure, but I gave it to them blank, but I only shared mine with them, I didn't let them edit it, does that make sense, they could just view my exemplar.
Do you think there was too many scaffolds? Cause like, I think about
I
your
don't know though, because like I still was in the same boat as Megan, that I had some blanks, and it's like, what were you doing for 4 days, like,
I just think about the high kids, cause when you give them too many scaffolds, then they're gonna follow it, and then you're not really seeing what they
you
actually know.
don't get to see what they actually, I could agree with that.
Right, there's a balance,
maybe I
right,
should've
between like too much guidance.
Split the groups a little,
First
you know.
idea of just giving them kind of a template, this is what I expect here. And then you can go above and beyond that, and then I would say for the lowers, then show them
Then
the
do
exemplar.
that, yeah, like hold the scaffold back until there's kids that are feeling, that are actually stuck. I do kinda wonder if I scaffold too much on that, cause like, they kept asking me, can we see yours again, and I was like, oh, I already shared it with you, and I was like, that might have been a trigger of like, I shouldn't have done that, you know?
So for your
So like, oh, we
highs,
just
I
have to
would
copy
say
this.
take it and go with the checklist.
Yeah. That's
And then your mediums, I would give them the template, what you expect on each, and then your lows, I would show them an exemplar, and have them create it based on that.
So would you like assign the exemplar and template to each of them, or like just go around like based on grouping?
Well, it seems like how you gonna know, because it seems like your groups are heterogeneous, where you
Yeah.
don't have,
The same
maybe
ability.
you
how mine
have
kind of is in
more
science.
scaffolds in your groupings.
Mm-hmm.
So actually
Okay.
like intentionally put kids in certain groups.
Yeah.
Yeah, that would inform that.
Yeah, something that I wanna really focus on next year for the school is, ability grouping. I mean, when is it okay to, make homogeneous groups together, and when is it appropriate to do heterogeneous groups together? If we had to like pick one for this, I would think that like homogeneous groups, for this, like what you were describing, I think would be like super cool. Where you had like, you know, kids of the same ability in the different groups, that way you know where the scaffolds, or which, how much scaffold each group needs.
Yeah.
And you would get some like, I think you would get some serious
I
outcomes.
think the other way you can get there though is to have the past teachers give advice, cause like it takes a long time to like study kids and know kids.
Megan knows
But I
exactly
do.
which group, which kids.
No, but I mean, now I do, I'm just
Yeah.
saying, like,
At
what
this
would you
point in the
do
year.
for
Well,
the
that's
first
how
half
you
of the
learn,
year?
yeah, for the first
Yeah.
half of the year, you do this, and then
Yeah,
you find out
okay.
immediately
Okay.
which groups, you know, for the next activity, which groups. move
Informal
on.
assessments.
Yeah.
You know your
Connect
kids
with
better than
ELA
anybody.
teachers, cause that's probably like the look into, really,
Yeah, yeah.
What's
yeah.
that?
connect with your ELA teachers, cause it's all gonna be about reading and writing.
Totally,
Yeah.
totally.
Well,
Well,
and
and
then,
also like,
I
you know,
asked
the
the
SPED
sped a lot.
teams
too.
that like need chunking, more chunking, you know what I mean? Like I do strategically pair my SPED kids in science for the ones that need more chunking.
yeah, I just think well, it's important to know when it's appropriate and when it's not. I mean, when do you, I had this conversation with the math teacher the other day about, doing an exit ticket, but letting the kids work together on the exit tickets. But I think that's okay, but if you really wanna gauge what the kid's capable of, then you have to like, you know, do it individually. But that's situational, so Megan,
And for
what,
projects, I think it's different too.
right,
Yeah, like for that
Exactly.
Pokemon project, I told them they could work in partners, they got to choose their partners, but like, I understand that if it wasn't such a free project, I probably would have been better dictating the partners, but I
It's all
still
about
made
what
them
you
turn one
want
in,
really
you know what
out
I
of
mean?
it.
Yeah.
right. And then that goes back to this checklist. I think if you do this, my encouragement is if you break down a standard like this, then you can see if the checklist matches your breakdown, and then you give your kids, you know what I mean, you give your kids guidance accordingly. If you wanna add to this checklist, obviously, they're there for a reason. I think that somebody did a lot of work and said, these are the things that I know, or we know that if we see this outcome, it's gonna be a good project. So, Megan, what have you heard here today that you're gonna take back with you for your next, kind of project like this?
I'm really excited to do like the scaffolding on different projects, tiered
can't bring it to me.
I don't
Homogeneous
have it,
grouping.
I know. It's in my room,
Yeah.
my office somewhere. My wallet's in my office,
Okay.
either in a drawer or something.
Alright.
Find it.
Sometimes I feel like it's easier to group people based on behavior and who works well with not their friends, and you can't always have both, you know what I mean, not their friends and their like scaffolding, you know, partnership. Wait, what?
For let them work with their
That's what I mean,
friends.
so like I'm very dead set against not letting them work with their friends, and sometimes like there's 2 or 3 kids that like are just, they would be lost unless they had the higher friend, because they work better with them.
I know, but I think it's
You know what I mean?
situational. I think it's
Yeah.
dependent upon, like we're talking about right now. Sometimes there's a time and place for that, but there's also this learning process that the kids have to go through, because, you know, sometimes it's okay to work with their friends. I think if the management is set up right, any kid can work with any kid, you know this. But, I'm sorry, you were saying that you're excited about what before I'm on the
Oh,
phone?
no, just scaffolding, the, like tiered scaffolding
Mhm.
and homogeneous grouping. Like showing, like either just giving the high case just the checklist and then showing a template and then showing exemplar
Yeah.
for certain students.
And I think you're right, I think this is modeling, and that modeling is dependent upon those groups that you make.
I would even do like, when they're working like a station rotation, like with the 3 groups. So the
Mhm.
highs, this is your expectations, the mediums, the lows.
Do
You
you
guys
like-
have enough
yeah.
time for that.
Yeah, do you address them like that? It's like if you are for high level or like how
This
do you?
group,
Group 1, group 2,
Group
group
one,
3.
you're doing this, group two, you're doing.
And they don't know or, okay.
Sometimes they do, but,
And sometimes they put up a
I make
fight,
some
I'm like,
groups
why is
often,
this
they never
person
know.
allowed to have
Yeah.
that, and why
well,
is
see,
this
like,
person allowed
the
to
thing
have
is,
that?
if you mix it up enough, and sometimes you're doing heterogeneous groups, and then sometimes you're doing homogeneous groups, it just, the kids aren't necessarily gonna know. I think the kids know more when they're being separated for, different reasons. That's why I love our inclusion program here, our push and model, because like special ed kids know who they are when they get pulled out to another whole building, you know, that's different, I think, than strategically, grouping kids for different reasons. Cool, thank you, Megan.
Yeah, thank you.
Big snaps for Tran.
That's so really brave of you. I feel like I always kind of skip it in here.
I know.
I have to, cause we only have